Alright, here's the third question from the Heroes Formula problems. This one says, determine the area of complex shape ABCD below. That means from A to B to C to D, I need the area of these two triangles combined. So I'll call them triangle 1 and triangle 2, because I'm pretty sure I'll be working with them separately. Now over in triangle 2, I've got two side lengths. I would need this third side length to be able to use Heroes Formula. In triangle 1, I have a couple of options. I could find this side length pretty easily using SOHCAHTOA, this angle pretty easily, and actually I'll do that now. I'll do 180. This is a right triangle, number 1. Notice the box in the corner here. So 180 minus that 90-degree angle minus 30 is going to leave me with 60 degrees. This angle right up here is 60 degrees. So if I find this side length, which I need for triangle 2 anyways, I could use the A times B times sin C area formula to be able to calculate the area of triangle 1. And I think that's the way I'm going to do it. Another way to do it would be to find the third side length of triangle number 1 here and just do base times height divided by 2. I find the A times B times sin C divided by 2 formula pretty easy, and it means I don't have to find this third side length. So that's the one I'm going to do. Starting over in triangle 1 here, I'll redraw it to make my life a little bit easier. I've got this 60-degree angle, and I'm actually going to work with this one. I've got a side length of 60 here as well, and what I'd like is this side over here. So when I label my right triangle for SOHCAHTOA, my hypotenuse is always across from the 90, my opposite side is across from the angle that I'm going to work with, and the third side is adjacent. So here in SOHCAHTOA, I want the one that works hypotenuse and adjacent into the same formula. A and H for adjacent and hypotenuse are right here in the cosine version of SOHCAHTOA. So that means that the cosine of 60, because that's the angle I'm working with, is equal to adjacent, x in this case, divided by hypotenuse, which is also 60. I'm going to create equivalent fractions and solve for the missing side length by cross multiplying. So here to cross multiply, I can do 60 times the cosine of 60 divided by 1. Remember, I multiply my diagonals, divide by the other number. Press equals, and I get a side length of exactly 30. So 30 equals x. It's a nice easy number to work with here. My side length is 30. Now I'm actually ready for the area of both triangles. So still working in triangle 1, here's area. For triangle 1, I'm going to do A times B times the sine of angle C divided by 2. So that means 30 times 60 times the sine of angle 60 divided by 2. 30 times 60 times the sine of 60 divided by 2 gives me the area. So the area for triangle 1, when I multiply that out, 30 times 60 times the sine of 60 divided by 2 gives 779.423. See, it's 4228. That means that 2 would go up to a 3. That's accurate enough for this question. 779.423. That's my area for triangle 1. Now remember, I still need the area for triangle 2. For triangle 2, knowing the 3 side lengths and no angles, I'm going to use Heroes formula. Heroes formula says that the area is equal to the square root of s times s minus a times s minus b times s minus c, where s is a plus b plus c for perimeter divided by 2. S means semi-perimeter. So here, that's going to be, and I can call these any way I want, I'll call them A, B, and C over here. So A is 70, B is 80, C is 30, and all that divided by 2 leaves me with an S of 70 plus 80 plus 30 divided by, let's press equals first, divided by 2 means S is equal to 90. So when I'm filling in the formula, area equals the square root of 90 for S, 90 for S again right away, 90 minus A was 70, times 90 minus B, that was 80, times 90 minus C, which was 30. Now I got to solve what's inside those brackets before I can multiply. So I leave the 90 out front. 90 minus 70 is 20. 90 minus 80 is 10. 90 minus 30 is 60. I've got to carry out these multiplications before I can take the square root. So that's 90 times 20 times 10 times 60. That gives me 1,080,000. And that, square rooted, the square root button, equals 1,039.23. I wasn't given a unit of measure, so these are just in units for now. And they want the total area of these two shapes. So here, my total area is going to equal 779.423 plus 1,039.23. 779.423 plus 1039.23 gives me a grand total area of 1,818.65, and they wanted this rounded to the nearest integer. So if I go, the integer is before the decimal place, I look one space to the right, that's 5 or above, that means this has to round up to a 9. So my final answer here is going to be 1,819 square units.